Hello guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is perfect number. So in this question, we have given x, y and bound. So the main constraint is that main condition that is x raised to I plus y raised to j is less than equals to bound. Okay. So this is the main condition and we need to satisfy this condition, and if we are changing the values of I and j, that means x raised to power I and plus y raised to power of j, it value should be less than equals to bound. And there are some answers like this. So we can get these answers. How? Firstly, firstly we are talking about constraints. So for I and j, we have given this value should be less than equals to 0 and less than equals to 10 raised to 6. After that, bound. Okay, bound's value is less than equals to 1 or less than equals to 10 raised to 6. Okay, after that, x and y. This value is less than equals to 1 and less than equals to 100. Okay, this is the constraint that we have given. And by changing the value of I and j, we are going to make some combinations of this, and that combination, by using that I and j's combination, we are taking the sum of these two numbers and it will be less than equals to our bound. So our x is 2 and y is 3. So let's make some I or j's combination that makes this answer value of this. Okay, so I, let's take I 0 and j is also 0. So 2 raised to 0, 1 plus 3 raised to 0, 1. So 1 plus 1. Now 2 raised to 1 plus 3 raised to 0. Now 2 raised to 1 is 2 plus 1, 3. 2 raised to 0 plus 3 raised to 1. 1 plus 3, 4. 2 raised to 1 plus 3 raised to 1. 2 plus 3, 5. 2 raised to 2 plus 3 raised to 0. So it is 4 plus 1, 5. So the values are same. At this point, values are same. So for our answer does not contain same values. So for avoiding this, we are going to use state. Why not map? Map contains key versus value. We don't want that frequency map like okay. We don't want that frequency map. For that, we are going to use here set. Set contains only distinct values. Okay, only distinct values. Now 2 raised to next pair that we can make, the next combination that we can make, that is 2 raised to 2 plus 3 raised to 1. 3 plus 4, that is 7. 2 raised to 3 plus 3 raised to 0. 8 plus 1, 9. After that, 2 raised to 0 plus 3 raised to 2. 9 plus 1, 10. So all the combination that is present in the answer that we are made here, but we are especially make sure that it is not double repeated in our answer. Okay, it is not repeated in our answer. So we are going to use set here. So solving this question, for solving this question, okay, let's take this to another side. Okay, these are some combinations and we need to make sure that this is not repeated in our answer. Now for solving this question, our x and y constraint is 1 plus 1 to 100. So our x raised to i's value is always been a positive value, and y raised to j's value is also been a positive value. So our x raised to I is less than our bound, and also same for y raised to j is also less than bound. Why it is not equals to? Why x raised to I is not why x raised to I is not equals to uh, that means why x raised to I is less than equals to bound? Why we are not taking equals function, equals value here? Why why we are not using equals operator here? Because if let's say bound is 100 and this value is also 100, then 100 is less than 100. it is not possible, it is not a true value. Okay, so we are saying that both, if both are comes, then we are saying that it is less than equals to bound. We need to satisfy this condition. Okay, so if this x raised to i's value is 99 plus y raised to 0, that is 1, then we are saying that it is less than equals to 100. So 100 is less than equals to 100, and this condition is satisfied. This condition is satisfied here. So for that, we are not taking that, we are saying that this is not possible. Sorry, this is possible, this is not possible. Because if we are taking any number raised to 0, then it will gives 1 as the answer. Now let's solve this question. Our firstly, our x raised to I should be less than bound, and y raised to j is also should be less than bound. Okay, now for solving this equation, we are going to use a log here. Log. So log of x to the base x, log of x raised to power I to the base x should be less than log of bound bound to the base x, and for same for the y also. So let's write here log of y raised to power j of base y is less than log of bound to the power y. So for solving this, I is at this point. Now log x to the base x, it is going to be 1, is less than log x to the log x to the base of b. Okay, now at this point j is at this point, and log y it is going to be 1 and less than log y to the bound. Okay, so I is less than log of x of bound, and j is less than log of y bound. Okay, now we need to solve this equation. Okay, if we are solving this equation, our problem will be sorted. Now let's say that log to the base a of b, we don't know, so we don't know how to solve for log to the base a, but we know how to solve log to the base 10. So we are going to use here, that is let's say this. Okay, log to the base 10 of b divided by log to the base 10 of a. So applying this condition over this expression, so I is less than log to the base 10 of bound divided by log to the base 10 of x. So our x is what we are taking, what is the value that we are taking for the x in this equation. So for solving this equation, we are going to use the maximum value onto the numerator and the minimum value onto the denominator. So it can give us the maximum number of possible combination that we can make by using the I and by using the j. So the bounds constraint is it is less than equals to 1, and it is goes up to 10 raised to 6. So maximum that we can take here, let's change the pen color, log to the base 10 of 10 raised to 10 raised to 6. Okay, and at the divide part, log to the base 10 of x. So we have to take the minimum number here, minimum number that x can be produced, x can be start with, that is 1. But if we take a power of x, if we take a power of that means 1 raised to any number, then it will give us 1 as a value. So it will not give us some another different number of combination. For avoiding that, we are going to use 2 as a minimum value. So log to the base 10 of 2. So now we are solving this equation. So the log of 2 to to the base 10's value is somewhere like 0.2327. So we are taking the approx value here. I is less than here 6 is at this side, log to the base 10 of 10 divided by 0.3. This is the approx value, not a final value, approx. Okay, now I is less than let's solve this. It is a 60 divided by 3 and going to the 20. So at this point I is less than 20. Similarly, if we solve for j, it is also comes j is less than 20. So it is a very small number, very small number of combination that we can achieve by using this range. Okay, so our I and j's range is in between 0 to 20. So the number of combination that we can make by using this range, that is 20 into 20, that means 400. So maximum number of combination that we can produce by using this range, that is 400. So here let's say a raised to 0, a raised to 1, a raised to 2, and a raised to 3, and a raised to 20. Okay, similarly for b raised to 0, b raised to 1, b raised to 2, and b raised to 3. Similarly b raised to 4, b raised to for 20. Okay, so this a raised to 0 can make combination with all this 1 make combination with all this 2 make a combination with all this, 3 can also make a combination with all this. So for achieving this combination, we are not going to use the power function, we are going to use a for loop here. Let's see some pseudocode type for loop. So for loop, I is starting from 1 and I is less than bound. Okay, I is less than bound. After that, I is multiply equals to a, and let's try to print I. So this is the end of for loop. So let's try. I is at 1, printing I, that means 1. So 1 we can write 1 as a raised to 0. So any number raised to 0 is 1. So updating our I, it is firstly 1, updating our I as a. So a into a, that means a raised to 1. Updating our I, multiplying a into a, that is a square. So it is a square. Again multiplying a with a square with a, that is a cube. Printing that, updating that a cube into a, that is a raised to 4. Again printing that a raised to 4. So we can get this type of this type of combination by using this for loop. So for solving this question, we are going to use set or not. Let's see here, or not repetition of same value in our answer. Okay, now this is my approach. So from this we are going to code this question. So let's start with the code here. So we are going to use we are going to write a C++ code. So let's increase the font size. Now we are going to use a set here. Why? Because we want only distinct numbers in our answer. So writing here unordered set of integer, that is set. Okay, so we are traversing over the we are starting with the I with 1, and it is multiplying I, updating our I as a I into a, I into a into a into a into a. Okay, so I is starting from 1, I is less than bound, and I is multiply equals to a x. Okay, okay, x. Now starting our j loop from 1, and j I plus j is less than equals to bound. Okay, if this condition is true, then this I plus j makes some combinations, and if it is less than bound, then it is true for us, and updating our j as a multiplication equals to y. Okay, now inserting this value, insert I plus j combination into our set, so it gives us our answer. Now we need to make sure that our x or y should not be equals to 1. If it is equals to 1, so it gives us the loop will be goes into infinite loop and it will be not terminated. So we need to make sure that if our y is equals to 1, red pen, if our y is equal to 1, then our this loop is going to multiply y with y, that means 1 with 1, 1 into 1 into 1 into 1 into 1. So this loop is going to infinite loop and it will be not terminated. So for that we need to make writing that if our y is equals to 1, then break from this, break the loop from this. And also for x, if x value is equals to 1, then break from this also. Now after that we need to return this answer into vector array. Okay, okay, let me clean this first. Okay, so we need to return our answer into vector array. So we are writing this as a this our set dot begin, okay, and set dot end. Okay, so this is our code. Let's try to run this code or the sample test case. So it is run successfully. Okay, and it is in sorted order also. Now what we are doing in this code, let's try to figure out. So the first for loop is making the combination for I. Okay, for I, that is a raised to 0, a raised to 1, a raised to 2, and it is goes up to a raised to 20. And the second for loop is going to make a combination for b raised to 0, b raised to 1, b raised to 2 up to b raised to 20. Okay, so by using that we are achieving the 400 number of combinations here. And if we are we are inserting the values that combinations into our set and returning that set from this point. And now at this position, if our y becomes 1, that means our value of x and y is lies between 1 1 is less than equals to x comma y and less than equals to 100. Okay, so our x comma y is less than equals to 1, so yes, greater than equals to 1 and is less than equals to 100. So this y can be y can be 1. So if y is 1 at this point and j is, then our operation will be 1 into 1 into 1 into 1 into 1. So this loop is uh, going into infinite loop and we need to terminate this loop. So we are saying that if y is 1, then break, and for x also, if x is 1, break. So this is the code and this is the explanation for this question. So I hope you understand the question and the solution of this question. Thank you for watching.